Sir, I forgot to submit it.
Dangerous. You are living dangerously. All right, listen, guys. What I want to do today before I move on into the next hour is to do some reinforcement activities relating to coding, since we will not be we'll be doing a mixture of defining diagrams, pseudocode, flowchart, and programs, since we will not be necessarily coming back to this. We won't have the time to. I want to do some reinforcement for the first hour. So can I ask you to download lesson 3 of algorithm 7.1? And then what I want to do is to start attempting to work through those challenges on there. And we're going to go through them, give you a chance to improve on your answers. And then what we will do after that is that we're going to move into talking about loops and arrays, which is as much as your syllabus requires you to know. So we want to make sure we are covering those in real time. Please remember that to be efficient at programming, you have to be willing to try and to practice. And as I say to my students, you don't be afraid to get things wrong. You learn more by getting things wrong in this aspect of IT. Yeah. Oh no. So Jade, what you have going on there for you? You got data? So yeah. Oh, okay. Nice, nice, nice. You're gonna have to go back to the foreign country there. All right. Leave Jamaica.
Sir said listen to your lesson 4.
We're gonna do 3 first, and then if we have time, we go into 4. Lesson 3 is going to be just sequence, more sequence activity. Lesson 4 is more selection activities. So yeah, for the first part today is to get one of those done or 2 of them done. If you don't, you'll get 1 for homework. So yeah, let's see how fast you can work. Deandra, let me know if you can access the file, or you'd like me to throw it in the chat for you. Not Deandra. Deandra, good. Who else always I said them can? Katrina. Let me know if you want me to throw it in the chat. Maybe I should do that. Make
Yes, sir.
Okay, that's lesson 3 there in the chat. And this is going to be lesson 4. Okay. So take a look at those for me. Yeah, maybe I should do 1 first, shouldn't I? Let's start with 1. Let's start doing 1, and then see how you get on with the rest. All right, so I'm going to do 1 of them with you, and then set you on your way to carry on doing the others. So usually, when you are going to write a program, whether it's in the real world or it is in school, you must get something called a problem statement. From what we did in our previous lesson, a problem statement is a clear explanation of the problem you are trying to solve. A problem statement is good when it has some form of input, so we must be able to identify the input. We must know what we're trying to print, which is going to be our output, and then we must come up with a strategy, which is what the process is in how we're going to solve this. Now, usually you can tell the input if it follows words like accept or enters. It basically tells you what you're going to enter. Output will follow words like result, show, print, blah, blah, blah. It basically tells you what you will have as success. And then your process is going to be basically the steps in how you're going to arrive at the output. So let's try and go for this one, for the first one. So what would you say is the input in this first question?
The name and price.
All right, so that's name and that's price. All right. Anybody not understand that? Okay, not understand how to recognize that? So the first part of the statement did say we're going to enter the name and price, which tells us that's the input. That's what the person will be expected to enter inside the program. Okay, what is going to be the output?
The total, sir. The final total.
Final total. No, there's a slight problem with this. So it's final total. There's a slight problem with this question. Notice they said the name and price of what?
3 items, sir.
Which means that we need to have 3 names and 3 prices. So I am going to call, I just said name one, and whatever that first name one, but whatever that first item is going to have price, it's going to have a price. So I'll just say name 2, and that is also going to have a price, which is price 2. And then there is a name 3, and it's also going to have a price, which is price 3. Is there everybody not understanding that? Do I need to explain that again?
No,
All
sir.
right, cool. All right, so reason for that is that we're taking in 3 items. So it's like, this is like a program for a small shop, right? Persons can buy a maximum of 3 items, and each of those items will have prices. And we now need to work out how we are going to find the price, okay? So now we're going into the process. The first thing in the process is that you need to tell the person what they need to enter. So you could use 3 separate print statements, or you could use 1. Since we're basically building our programming skills, we're going to be absolutely basic, and we're going to say print, enter first item. We'll enter the name of the first item. All right. Now, because this is meant to be a prompt statement, it is a string, it is always advisable and wise in programming to put them in quotation mark. Because I'm just going to use this to do my pseudocode later on, I'm going to make sure keywords are always in uppercase. Because in pseudocode, we start to distinguish between commands and regular words in the program. Now, if it is that you ask them to print, this is only going to put the statement on the screen, show them the instruction, but it doesn't accept or allow them to enter anything. So what actually allows them to enter is our input or our read statement. So we could use input or we could use read. If you went to the exam and you saw input or you saw read, they mean the same thing. It needs to take something from the user. So we're going to take in the first name. So that allows the person. This one tells the person to enter. This one accepts the first name that the person enters. Okay? The name one is just a variable. Are we going to repeat this again? So we'll just copy and paste this for now. Make my life easier. Enter the name of the second item. And name 2. Second. I do the same thing again here, which is third item, and put name 3. Now, notice what we haven't done yet is to actually enter the price. Now, because it makes logical sense for me to ask you to enter your name, then ask for the price same time, I'm actually going to go back here now and enter the price there. So this time I'm going to say enter the price of the first item. This time we're going to be storing it inside the variable price 1. So remember, the keyword price here only allows whatever the person input from the keyboard to be stored in a variable called price 1. Okay? And I'm going to do that for the other items here, which would be this one. So we don't just want the name, we need them price too. This one is for the second item, into the price of the second item. And we will store that in price 2. We will repeat the same process for this one. And that would be for the third item. Third. Now, we would then input into price 3, all right? So that is, we're not done. Those are just logical steps that we're going to be taking to solve this problem. Now, how do you think we're going to find the total cost? What do you think we need to do?
Sum equals.
All right, cool. So we're going to call it, we have to call it summing, man. We don't want to not be static as programmer, you know. We can't call it here, but anything will make sense. So we're going to call it total today, all right? So it is price 1 plus what?
Price 2.
So why am I not add name 1?
Because you're dealing with the price, sir, not the name.
Fabulous. All right, good. So we're going to go with price 3. And the last thing that you're going to do is to
Print total, sir.
so we print total. All right, so nice to always have a nice sentence to show the examiner that you're bright and you come from good school and good teacher teach you. All right, so the total price, or since I said the final total is, remember we have a little comma here to show concatenation. We just join in the verb.
Yes, sir.
So everybody happy with that? Any question? Any question?
No, sir.
Katrina,
Sir.
we nice? We nice, Katrina?
Yes, sir.
All right. You see, if you write a secret about writing a very good IPO is that if you have a good IPO, you have an excellent pseudocode, and you also have an excellent program. That's always the secret. So if this was done properly, look at this. All I now need to do for the next question, that is right, pseudocode. Now look at this. It will. Oh gosh, just like that. Take up everything and carry it come right down here. So what we must put up a top?
Start.
Start.
But just before start, we should have declared with what? With variables.
Declare.
So.
Yes, sir.
So what were my variables again? Name 1. We have name 1.
2.
Name
Yes,
2. Name 3. And what kind of data type are these? A name is a what? A string. So the data type is string for words. Remember that, right? So data type as string. We can't use the same line to declare the others. So now we have to declare them separately, you know what I mean? Because them one, they are what? They're going to be values. They are values, they're numbers, right? So we will do what was it again? Price 1. Price 1, comma, price 2, comma, price 3. 1 missing. Anybody know which one? Which other variable not declared?
Total price, sir.
Total. Right? So there you go. Total, and we declare them as real. Right? Because we know that something can cost $45 20 pence or 20 cents. Sorry. I could. So you want to do that, right? So that is how we get here, right? So if you had a very good defining diagram, the rest becomes easy. The only thing you have to do, you know, I kind of indent this in. Oh no, you have to use the space bar. So use space bar and you put that in so you show them, so you know this is actually a part of a program. See that? All right. Yeah, man. Yeah, man. Yeah, man. See that? Do that right over there. Do that right over there. Do that right over there. Do that right over there, sir. Yes. Right over there. I wonder if Jaddy is still around. Our internet gone. All right. Anybody here from Jaddy? She there?
You're still here, sir.
That's our name, did I? Internet must have gone. Yeah. So go man, you know, once she lived down, I know word started B, man. Last time she quarreled with me.
She's there, sir. She's there.
Whoa. So what should go here now? What's the last thing we do here?
End, sir.
All right. So me like for use the convention. You see, me I use start, me deal with stop. If me I do begin, me deal with end. Either way, a smart examiner should not be giving you something wrong because of the jargon where you use. That is just my preference. All right. Fabulous.
Yes,
Here's
sir.
the next
Yes,
thing
sir.
now. So when we do flow chart, guess what? The only print statement we need to show in our flow chart is the one where you actually output the result. See, so if I now output a result, they're going to ignore that one because guess what? In the flow chart, I don't need to represent prompt statement. Remember, these are prompt statement. Let me write it beside it. This is a prompt statement. A prompt statement just simply tell the user what to do. Tells user what to do. Make sure not take notes, no. So that this is the although them still use the word print, they are different. This one is not a prompt statement, it's an output statement. And by output, I mean it displays result. Right? So it displays result. So we do not represent prompt statements in our pseudocode. So as to guide you then, one of the things I normally say to persons is in your pseudocode, you don't in your flowchart, you're not declaring variables and you're not showing prompt statements. Somebody needs to write that somewhere, you know, just pinch it somewhere so you remember. In your pseudocode, sorry, in your flowchart, you should not include your variables, neither should you include your prompt statements. Which then means the only thing we're gonna need right now is start. It's like me, you know, life go through and I like the things I'm gonna need. So it's when me I draw, yeah man, I know what I'm doing, you know. Yeah, there's no room for failure. You know what I mean? So I'm setting myself up for success. All right. So I ignore prompt statements and I also ignore declarations. They are not necessary. So the things then that I need are these things. Good. Right? That's it. Because this is oh, missing one, right? The output. Need to have the output there. So that is what I will need to represent in my flow chart. So can I now ask you to go to draw.io? Draw.io. Yeah. Yeah, man. Let me get a new one. Sure. New one. blank one. No? No, man. That's why I must fire Digicel. Please fire Digicel or Flow. One of them. One of them. Just get rid of them.
Sir, Flow is the better one, sir. So I think it's the digital she's using.
Usually when me come Jamaica, me use Flow, but then let me down ever so often. I have faith in none of them. I would like the country to just get rid of that those companies. Just get rid of them. Let's go Starlink. Sure. Now this is
Yes, sir.
DNA.
That's the way, sir. That's the way.
All right. So you guys should be making your flow chart now. Can you all see my flow chart I'm making? No? All right, let's
No,
try and
sir.
fix that problem. All right, let's fix that. Can you see it now?
Yes, sir.
Good. All right, so we are go through. So we need to input name one. We need to input price one. Boy, I like when the flow chart this long, man. So input. So when them long, you must give them to students to do, not teachers. So, yeah. Student must always have a lot of work busting their brains. Yeah. Give me time to sit at my table and drink my coffee. Every now and then, just look up front of my glass and just say, D'Angelo, you getting on? Oh, sure. D'Angelo, that sound like one of your teacher. That just sound like what that just sound like what one of your teacher that do.
Sir, probably, sir.
Sit down on the desk and just give a whole heap of work and just by desk and chill. Come on, students, you need to hurry up. We don't have forever. Oh God, we made this alien so. The fault. Fix it up. Nice.
Sir, none of it is my fault.
Here we go. Here we go. All right. Now we need, what do we do when we are representing the total equal? Which shape do we need?
Rectangle, sir.
Rectangle. That's a process. Fabulous. Jesus. I am so plentifully proud of you all. Well done. Only they add the spice into my weekend. I mean, just mark some of the students' exam paper, and fabulously proud. Yeah. And some of me think now learn a thing. Never look too bad at all. And say, yeah. Few little mistakes, I can fix those for the exam. All right, so good. So we on to now price 3. Then we move right into another output. Again, you see all of the fancy description where you put in that for the pseudocode, man, or for the program. That is there so that you make the program usable. But when it comes on to the flow chart, we just need to show the logics. So guess what? We don't need to put an extra in this, we just need to print total. That's what I'm saying. That's all I need to do because the goal here is to just show the logics. Remember that your flow chart is meant to show the logics, right? You don't need to be user friendly. Cool? Now, next thing that we do now is to end our program with a stop. Put on a nice stop there, STOP. And then we don't know now if you go and go show the data flow. Of course, else it is not a flow chart. Make sure the arrow them are going in the right direction, you know. You see if you don't bet them go up, sure. Everything wrong. All right, done. Just like that. All right, that is that. Are there any questions? Especially my
No,
very
sir.
silent people.
No, sir.
Where is Rajane, Malik, Wagwan? Nobody answer nothing. Just a mute there. So I go, nothing. All right. So I don't know, so I must take a picture of this. I don't know. Nice good picture. And then I put it on the worksheet. Now, as I said, I did I do the first one for you. And then I'll go on some work for just work through and solve the rest. By the way, I just 25 minutes now go off. Done. No, now I go slow like me, and I go fast like both. Don't know. Shelly and Fraser and I come from a country where people them well fast. So now go sprint. You know what I mean? Cool. And nobody ask me if me fear, come now try to be fear. Now, next thing we're gonna do now, we're gonna go on over to the trinket side, you know what I mean? So I'll just pull up on the next app, which is Trinket. And I don't know where I'm gonna write the program. But when you get onto Trinket, you know, you click on the home tab right up here. And you don't know, you choose Python. All right? Yeah, man. And what we're gonna do here now, we're gonna implement this in Python because the goal here is to teach you all 5 concepts at once. Because I don't ever want my students to ever think that these are different. They are not. Everything we have done up to this point is a problem-solving component. Now we are moving into the program implementation component. Now, I want you to write down this little note somewhere. Write it on your book. Write it on your book. Write it on the book. Write it on a book, on a page or whatever you have, yeah? Find a little space on the thing and write it because we need you to understand this, right? We are teach all the things in one, but we are condense them to one thing. So we can keep focus, yeah? So what do I want you to write? Let me tell you. So, program implementation. All right, just write that. This is writing a code in a programming language. Writing a code in a programming language. That is what we mean by program implementation. Now, there are different types of programming languages. Come on, add that. Come on, guys, add that. There are different types of programming languages. All right, everybody got that? All right, so let's start with the 2 main categories. 2 main categories we have is low-level programming language. Type that, low-level programming languages. And high-level programming language. Okay. Everybody have that. All right. Now, on the low level, you're going to write, because low level in 2 categories, you know. So, category 1, yeah, low level. That go on like me, I take notes of that. So, Low level, number one. First generation language. First generation languages. So I'm not supposed to have it, Should not do it properly, So I make no problem over there. Now, the acronym for this is 1GL. Okay, cool. Now, with first generation language, we first generation language, we basically write this in something we love to call machine code. So let's go for it. I'm going to start by giving you this. So number one, machine code. Write that. Machine code. So that's number one. So here, the instruction is written, is written using binary. Anybody remember what binary consists of? Can't believe. 0 and what?
1. 1s.
Yeah, zeros and ones. Cool. That's machine code. Now listen, please. Everything the computer understands is implemented in zeros and ones. Okay? Remember when we were trying to convert different numbers or different letters into binary? Okay? No, there's a problem with that. It is difficult to code. So if we were to talk about disadvantage, it is difficult to code or difficult to write and debug. Does anybody know what debug mean? Make sure not take notes now.
To get
does
rid of
debug mean?
bugs, sir. To get rid of bugs.
All right, but even before you get rid of it, you have to first find it.
Find the bug. Yes, sir.
Finding and fixing errors. All right, good. So put that in a bracket, right? It's difficult. Why? Because zeros and ones not easy to understand, and many of us are not mathematically inclined. And I'm not calling any names. I'm just saying that's just the reality of how we are as human beings.
Yes,
so
sir.
it is then easier for us to write in another language that it is easier to understand. The first generation language was machine code. All right, cool. So, and as we say, the computer, this is what the computer understands best, right? Which means that it is faster to execute. So if I already write my program in zeros and ones, the computer will be able to execute that much faster than having to go through a process of conversion. All right? Which now takes me to number two. We have what is called second generation languages. So I'll go on. No, the shortened form for this, the acronym is 2GL. Now listen now. This one is actually called assembly. So the second generation language is called assembly language, right? So that is it. Remember, first generation language are machine code. Second generation is assembly code. Now watch this. This uses mnemonics. Let me see if I can spell mnemonics. I think so.
Oh,
Yeah.
that's never mind, sir. I forgot the definition for mnemonic.
Abbreviations.
Yes, sir.
Oh, right. So yeah. No, I use abbreviations, but all right. Abbreviations sound like grade 6 reasoning. That's what they would remember. But mnemonics for you is shortened instruction right? That represents certain certain code. Oh no, no, send me I go boss no. Come back with something extra right now. A boss. Search up for me little man computer. Let's see how it works. Come on, want to go now a little bit of a free experience, you know. Sure. John. I have to make sure so I get more than one that I get at a regular school. So let's go. You don't know we are not regular school. We are just over here. Search up the thing called Little Man Computer. Now this is a special type of simulator that helps us to understand how the CPU works and how the CPU take basic instruction and implement them. This is what you're looking for, right? Your computer should bring this thing up. All right, this is this. So we're going to write a couple of instructions into assembly language code. I'm going to show you how mnemonics actually work. Now, did you remember when we were talking about the CPU at the beginning of this course? And we said that the CPU have different parts. So we have the arithmetic logic unit down here. So this is the entire CPU. This over here is the RAM. And the RAM is storing data. So this, where you see the 000s, this is going to be where the data is stored. And this is kind of like what the address is. Because RAM stores the data and the address separately, right? So this is the address for the data. And this is the data that is going to be stored. Now, this is a bit above your level of curriculum, but it would have been helpful. That's why I think they need to rewrite the curriculum so you guys can have a better understanding of the things that they're telling you about, because all nugget is a bunch of theory but don't make no sense unless you're actually doing this stuff with it. So the CPU is actually made up of some different type of registers. We have what is called the memory address register. We have the CIR, which is the and we have the MDR, we have the PC. Anyways, let's try and write a basic code, show you what mnemonics is. So let's say I wanted the computer to accept two numbers and print the sum. This is what the code of this would look like. All right. Let me know if you can see me. So programming is the same regardless of the language, right? So put it this way, right? So in INP is the form of saying input. So that's a mnemonics. So in assembly language, we would use the INP instead of the word input, right? Code. So I'm going to input num1. Okay? No, you would use read or whatever. Now we need to store. So in assembly language, you actually have to store anything that you input. But now I'm going to have to use the abbreviation or the mnemonics for storing. That would be STA. And then what am I going to store? I want to store num1. Okay. Now I'm going to repeat that because I need to take in two numbers. So I'm going to go input, and then I'm going to do num2. And the next thing I'm going to do is to store num2. So if you notice, all programming, regardless of which language you're doing, is the same procedure, nothing different. You're just implementing it based on that rule. Why am I doing all of this? I want to see what mnemonics look like and how that actually work. Okay. Now, so now I've asked them to enter the numbers. The next thing I want to do is to add the numbers together. So what I think is you have to load. So we have what is called LDA, which is to load num1 into the accumulator. The accumulator is going to be right here. So the computer needs instruction to do everything because this computer is not as smart as many people think it is. Actually, it is very brainless. All right. So the next thing we need to do now is to add num1 to num2. So we use the abbreviation for addition, which is add. We add in num2. Load num1, add num1, num2, think so. Think. If I'm wrong, I'll fix it. All right. After we add num2, the next thing we do is to output just like what we do. But we use the abbreviation for it, which is out. Cool. And then, of course, from here, we would then stop the program. This computer is so dumb, you have to tell it when to stop, or else it runs continuously. Now, With assembly language, you actually have to declare variables, right? So just like what we do in a pseudocode, you have to declare the variables. So to declare variables, the variables that I have here are num1, right? So I'm going to declare num1. You'll type them the same way. And we use the abbreviation DAT to declare. Now, when you're declaring a value, right, you have to assign it a starting value. For those of you who write programs at school in Pascal, you would also recall that you also have to declare. Beautiful thing about Python, it saves you that unnecessary work and you don't have to declare in Python. But if you are using any other language, C, C++, Pascal, assembly language here, you are going to have to declare your variables. Anyways, I'm going to set my starting value to be 0. It doesn't matter because whatever the person enter is going to override what is at 0 anyways. Okay? Next thing I'm going to do is to go to num2, and then I am also going to declare that and set it at 0. Okay? Once that is done, program done, you know. So we're going to click submit. So the program is now submitted. Hurry up and get ready. I'm going to run the program. So now look what I go on, you know, I speed it up. Right? So now it is going to ask me to enter a number. So let's say I want to add 5. So I'm going to enter 5, press enter, watch that. And then it's asking me to enter the next number. So I'm going to enter 7, right? Because 5 plus 7 should give me 12. This is how we're going to know if the computer has interpreted the program I just wrote. So press enter. If you look up at top here, you notice the output is now 12 because that is the answer. All right. So the point I'm making here, I just did that to show you what assembly language looks like. The assembly language actually uses mnemonics. So from this exercise that you just saw me do, you can then theorize that it is easier to code in assembly language than it is to code in machine code. However, it is more difficult to code than it is to code in languages like Python, which is high-level languages. All right? Let me know if everybody understand that. Good, 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 good.
Yes, sir.
All right? What me not confuse nobody, you know. All right? Good, 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 good. All right, so back to our writings. So that is what we mean by mnemonics over on that side. All right. So let's see what else you need to write about that. So we know about that. Cool. So let's give an advantage here. It is easier to code in assembly than it is to code in machine code. All right. Now, we can also see that it is going to take longer. It takes longer to execute than machine code. The reason for that is the computer has to convert. You may not have noticed because it happens so quickly. The computer has to actually convert the assembly code, right? Which is mnemonics. Remember, the computer still don't understand ADD and SUB. It needs to convert that into machine code and then provide the result that is needed. So it is a tot slower than it would have been if we just write everything in machine code and done. All right? How's everybody doing? How's everybody doing? Next thing we're going to talk about today is third generation language. All right. No. Meaning if you separate this under, meaning if you call it so high level, right? Please see that. So first and second falls under low level. High level is third generation languages. We call it 3GL. No, with third generation language, no, you know because we have been writing in Python, so that should be easy. So they are designed to be easy for humans to read, write, and understand. They are designed to be easy for humans to read, write, and understand. Another thing we know about them is that they are written using English-like words. They are written, oh boy, I mean, I think I can't spell it. They are written using English-like words or English-like words. Bearing meanings. What's a bearing spell? No, tell me now. Bearing meaning
It's
that,
BEARING, sir.
you see me talk about barring that, you know? Bearing meaning that we can relate to. What do I mean by that? When you see the word input, you kind of have an idea from your English background that input means to enter. You already, by virtue of your background, knows that the word outprint means to output or to produce some form of result. So it's easier for you to relate to. All right. But what you're going to notice, this one is going to take even longer, right, to execute because you now have to convert this from the source code to object code and finally to machine code. This one is going to take you longer to execute. However, it is much easier for Uno to understand. Are we good? All right.
Yes,
So we
sir.
need to give some. Yeah, go ahead.
I can't see some of the notes, sir, for third generation because it goes past.
Oh, you gone past me something over here.
Mhm.
Yeah. I see me can't. So me not talk, but the thing you're right when me talk.
Can't
See
press
there?
it. My brain cannot process that fast, sir, to remember and then write it off.
All right. So examples of high level or third generation. Remember now there is fourth generation languages, and five generation languages. Those are used by AI. But anyways, I just want you to know that those also exist. Let me just look at your curriculum again to see if they want me to tell you about those, or they just want me to tell you the mere important bits for your level. Let's see what it says. Oh no. Ooh. Oh yeah. So they want to be able to distinguish between low level and high level. Okay. Machine and assembly, which we have spoken about. And they want us to tell you the examples of high level languages. So in some schools, they use Visual Basic. Every time I ask you what your school uses, you tell me something I know. All right? Something I know.
Sir, because I
Ah.
don't do IT in school, sir.
All right. When I was at St. Hughes, the most common one that was used is Pascal, and just because Pascal almost look like English language, right? But we kind of think it all, so I'm not interested in teaching or remembering it. All right. Now, if you go to sixth form, most sixth form schools that I know do C, and you don't know, so you have the whole family of C. There's C, C++, there's C sharp, that's C sharp right there. We in our class is using Python. If you don't go UE, you will use Java. Okay. If you go over America, they will use JavaScript. All right. So those are the different programming languages. So in an exam, they could ask you on the multiple choice to identify high-level languages, or they could ask you to state two high-level languages. So we want to make sure that we understand this. Now, the next thing I want you to write for me is steps in implementing. So that's your next heading. Steps in implementing a program. Steps in implementing a program. So, number one, very obvious. First thing you have to do is create the source code. Create the source code. All right. So when we write input num blah blah blah, that is what we call the source code. Let's give you a definition for source code. Because now we need to make sure that we are speaking clearly. All right. So talk about source code. This is the original human readable program written by the Anja using high level or low level programming language. So what I just created a while ago using Lickman computer is source code. What you have been creating and running through Trinket is called source code. In fact, I should add a little bit more on it. Before it is translated into a machine code. How's everybody? How's everybody? How's everybody? Everybody's all right? All right, cool. Couple of things I want to point out. I have addressed these at some point already, but I know I go already. We have to address these things again. Oh, you just find me over the place. Not done it. One. Two. So after you create the source code, you need to then what? Translate and or link right? Translate and or link. Now I want to make it clear here that this step is transparent. This step is transparent. You will not see it, but it'll happen. Right? So when you click run on the thing, this is what goes on in the background. You don't see it, but it is happening. All right, cool. Now, third step is execute. Another word for execute is run. I'm not telling this them thing, I'm execute. All right. In that same thing, so we're going to run the program. And then the last thing that we do is to maintain the program. Now let's look what maintain the program means. Okay. So, couple of things. use what do you call it now? Meaningful variables, which means that it's easy for you to recognize what they mean. You add comments to the program. And if you work for a big firm, you must create a user guide. Make it easy for people to use. So that's why when they build new invention, what do they do next? They create a user guide so that people can use it, you know, outside of the presence of the developer. How is everybody doing? We have not forgotten coding now. We're going back to coding, but I think these things are important because we have kind of been interacting with these already. We just haven't written them down as notes. And I want to make sure that people are cooking. So let's go. Next thing we need to talk about, all right, is types of errors.
Sir, could you extend the line? I'm not seeing the policy part.
Oh, so that's something, yeah, it be a problem. Go over more. Be unjust as you can see. See if that work. We better use one Word doc. We should use one Google document here, man. I see me find a Word file. Don't know. Don't try waiting. Put that over here. Right, listen. All right. All right. Look if that might better now. All right, cool. Let me know if that's good. No good with that?
Yes, sir.
Good. All right, so I
Yes,
look
sir.
at types of errors now, right? So when you write a program, there's a possibility that you will get errors. In fact, you are not a good programmer if you don't get errors. It means you have not yet done anything great. Syntax error is the first one. Now, let's talk about syntax, okay? Now, let's think about English language. How do you start a sentence?
A capital letter, sir.
And how do you end a sentence?
With punctuation, with the proper punctuation, sir.
And what is that, sir?
Full stop, question mark, exclamation point.
Fabulous. And if you start a sentence with a common letter, it is called what kind of error?
A grammatical error, sir.
Good. So syntax in the programming language is like grammar to English language. All right, good. So what then would we say syntax error is? It is errors caused by breaking the rules of the programming language. By breaking the rule all right, cool. All right. So let's give an example. Example. So in Python, using uppercase letters for keywords or commands. All right, let's make sure that we see that upon. I am going to put it in real life now. Real life, real life. Real life. So, on my board over here, yes? Let's say I was writing a program like this. I wanted a program. Oh, we want a program that does, what was the thing we're doing again? Name one. So yeah, we're going to do name one equal, and look at us now, input, enter the name of an item. What up? Should get an error. Error. What did I do wrong? What did I do wrong? What did I do wrong?
The input is capitalized.
Ah. So if I decide to follow the rule and put lowercase, yes, it worked. All right. Hence why we call it syntax error. The syntax error has to do with the rules being violated. You know what I mean? That's it. All right. Let's keep cooking. We're now going to talk about the next type of error. Is number 2. This one is called logical error. You know what? Let's say logic. Because I think Jamaica said logical. Let me see. Let me just look by it. Call it logic, call it logic, call it logic. They don't want any qualifying. It's logic error. Okay? So this one is errors where the program runs but produces the wrong result. Okay. And so the program works, it runs, it executes, but produces the wrong output. Let's test that. We're doing this in real time. Real time. Okay. So let's say I wanted to add 2 numbers together. Num1 is equal to 5, num2 is equal to 6. All right? And I want to find the total. Watch this now. Total is equal to num1, num2. Print total. Let's see if this works. Oh my gosh, it works. -1. Is that what I'm supposed to get, Deandra?
Sir?
Did I get the right answer?
Yes, sir.
Yes, sir.
Sure.
Good. Yes, sir.
Let me write to me this again. I want to add two numbers
Sir, you put a minus sign,
together.
sir.
So, did it work? It worked, didn't it? No.
Yes, sir.
Yes, sir.
Did I get the correct answer?
No, sir.
Because why?
No.
Because you wanted to add, but
But I did what? What is happening to my class, man? No, go get some coffee, you know. Let's go, man. Why is it wrong?
because you wanted to add,
Yes, but I did what instead?
you subtracted.
Yeah. So what me must do for correct, you know?
Add. Put the addition
Good.
sign, sir.
You know, that me a talk about. So there's an error in the logics of the program. Hence why it is called a logic error. If I went and changed that to a plus sign, now we would get the correct answer. So the error was therefore in the logics. Are we good?
Sir, I thought that was a plus sign.
Yeah. I go buy you one pair of glass, because it look like you want two pair. All right, cool, nice. Let's go to the third type of error now. We are doing everything in real time, you know, guys. We are show you how it works because we don't just want to give theory and see how it makes sense. So we're going to talk about runtime error now. All right, runtime error. My favorite to hate. So, right, for me, these are errors that occur while the program is running. Okay? These are errors that occur while the program is running. Let's go for an example. Is there anybody in here who have started arrays at your school? Nobody? Nobody. All right.
I
Good.
haven't started anything because I don't do IT at school.
Okay. All right. Let's talk about grade 11 people, them Katrina and them Jade. All right.
Yes, sir, Jade.
Yeah. All right. Listen now. Now go on a couple of examples. But I start with the easiest one. All right. I was supposed to know this type of error. Comment is out. Don't look at these. These are comment out. When you use a hashtag, you tell the computer to ignore. So those are ignored. So let's go. Oh my God, I'm getting an error. Why am I getting an error? Guys, me can't read mouth and lips, you know. Actually,
Not sure, sir. Not sure for this one.
Oh, come on, guys. Come on, guys. I can tell you no hate maths, you know.
I wouldn't say that, sir.
Who no hate maths?
I don't
Maths
hate
hate
math,
uno.
sir.
Guys, a number divided by 0 is what?
0.
Where you get that from?
Wait,
A
what?
number multiplied by 0 is 0. You see, I tell you that hate maths bad. Any number divided by 0 is an error. And no maths invent that. Computers from day one knows you cannot divide a number by nothing. That's just not making sense. This is why this is an example of runtime error. Let's give you another example. Now step up on the brain a little bit. Okay, so we talk about arrays, right? Students. So students of IT class. So an array allows us to store multiple items under the same identifier. And write it somewhere, you know? Write it somewhere, man. Write it somewhere. We're not there yet, but write it somewhere. Trust me. Trust me when I tell you. So an array allows you to store multiple items in the same identifier or under the same identifier. All right? Right again. Each item in the array must be of the same data type. Each item of the array must be of the same data type. All right, let's see now. So, one more thing. An array is created using square brackets. An array is created using square brackets. You're going to, in a minute, write the example on here, but don't write it yet. Don't write it yet. Let's put Colton in there. Hopefully I can spell Jade name. If I can't spell it, as I go.
Sir, I think it's on the screen. Well, not that screen, but
Yo, me not look for nobody name, brother. me just write something right now. See that? Hey, Christina, just open him right now. Just that me I say. Deandra. So I go spell it how me want. That me I tell you. Yo. Yo, I don't know, you know. I must see so. Who else their class today? Rajin.
Rajin, sir.
All right. The other people, them are bad people, them no go to class. Them no need to learn no IT today, Saturday. All right, anyways. Now, this is an array. Okay? So if I print students, it should print all of the items that are in here. So let's try that. All right. Oh, still have the full error up here. So run that now. So notice now it prints out all the persons in here. Now, one of the beautiful thing about arrays, yeah, you can access individual items in the array. Now, in Python, the first item in an array starts at 0. So let's go now. Colton is at index 0. Where is Jade?
1, sir.
Where's Christina?
2.
Where's Deandra?
3.
Where's Malik?
4.
Where is Regine?
Let someone else answer, sir. 5. Regine is 5.
Okay, I wonder what is going to happen if I print out 6. Print out 6.
No.
Right? Runtime error.
So I think,
Why?
sir, respectfully, sir, I think the coffee is getting to you.
Why is it error?
Because there is no 6.
There's no 6. Here you
There are
go.
6.
Runtime error. Well
There
done,
are
guys.
6
Well done.
names, but based off of the index, there are only 5.
All right, and just to prove to you that if we run 0, it should print Colton. All right, see, Colton. If we print
Yes, sir.
1, it should print Judea. So I'm not scamming you. And if we print 5, it should print Regine. All right. We're going to do more of this in the future. But this, all I'm doing here is to help you to see how these, how the content makes sense. So that's another error, type of error. So please write example of runtime error, dividing a number by 0, or trying to print an index where there's no value in the array. Okay? So those are 2 examples that you can write. Okay. All right. We have 2 more things I want us to write and then get back to programming today. All right. So next topic for you is test data. You're going to do that in your SBA. So you need to know test data. Next topic you want to write on is test data. Now, test data is sample input data that is used to check whether a program works correctly under different conditions. Okay.
So you're typing?
It's right there. Test data is sample input data used to check whether a program works correctly under different conditions. Everybody get that?
Yes, sir.
Good. All right, so as usual, we are going to test what I am teaching. All right, I need to make sure I'm testing what I am teaching. All right, cool. So let's look at test data in real time. If it is that I have a number and I am saying int input, enter a number. All right. And then I want to do a new variable called value. And I want to multiply num times 2. All right. And then I want to print value. Okay. When I run this program, I need to come up with some data to test if it works. Something that I need to enter that shows if I multiply, if I enter this, what will happen? So 4 will produce all right, let's run it again. So 4 will produce, see, 8. So the 4 entered there is test data. But what about this? I'm going to enter Colton. Oh gosh.
So that's very aggressive.
Enter Colton. Error. So test data doesn't have to be realistic. You can enter unrealistic data because the goal of it is to see how is the program going to react to the input that is entered. Everybody good? Talk to me, man.
Yes, sir.
No, guys, a long time ago, I explained the different types of data type. Did I do it last Wednesday, last week, when we started coding? Did we? So let's go back over them. All right, so we'll go to data types of data. Okay, so data types. So these are not strange because we have been using them. We just haven't written down any notes on them to make sure that we're ready for exam. So, right for me, a data type defines the kind of data that can be stored in a variable and what operations can be stored, not stored, performed, different, can be performed. Sorry. So if I define something as an input, as an integer, I am not then able, something as a string, I'm not then able to multiply that data because I define it as a string. All right, so that's important. Okay, let's look at the different types now. So different types, different data types. Right, starting with the numerical ones. Let's go numerical. So meaning from here, use these, you talk about numbers. So let's start with integer. So these whole numbers, which simply mean numbers with no decimal point. What kind of operations? They can be used for calculations. Okay, that's that. Know that. Next type that we have. Now, I'm going to tell you what it is called in other places, but in Python, we have a specific name. So if you're doing Pascal, it may be called real. If you're doing Python, it is called float. And if you are writing database, it is called decimal. All right, means the same thing. These are numbers with decimal point. Everybody good? Next, we have, so those are the two that you need to know. When you go higher places, if you're pursuing the subject, of course, it will be kind of more. So let's look at characters. These are more like, character purposes. So we have what is called string. Okay? And this just means a sequence of characters. All right? And then we have character. And this one is a single character. and we are going to bold this. Okay. Now, we have another type, which is called Boolean. This is another data type. Oh. So this one stores one of two values. And these two values are true or false. And it is used for conditions, decisions, and loops. All right. Look like everybody stop work now. We're done. All right. Okay. All right, cool. So let's get back to the programming that I started out on. That kind of conclude most of the theory that I wanted to cover today. Now, I wanted to go back to that first question that I attempted to answer with you. I'm going to write that program, and then I'm going to allow you to do some programs for us today. All right. I want you to do some program, pseudocode flowchart for us. So from the activity, so if we go back to the activity we started out with, we're going to rewrite the pseudocode that we did have So because we are expecting the price to maybe be a decimal number, we're going to go with float, and we're going to do input, enter the price for the first item. Yeah. We will repeat this because we're taking in about 3 different items. We could have done 2, and we're going to do 2. All right. Then we're going to go ahead and we're going to do the third one. Now, it is always good that when you write a program, especially when you're just starting out, that you run it ever so often. We call it iterative tests. So we keep on testing to make sure it's doing what we wanted it to do. All right. So in this case, Let's say I enter Bulla. All right, one Bulla Africa, how much in Jamaica? $80?
100, sir, or 120.
I saw Bulla there. How
Yes, sir.
much banana chips?
I don't know, sir. I don't
120,
like them. I
sir.
don't eat.
How much?
120.
La, we can't live in Jamaica, dog. God, no, no.
Inflation
Sorry,
is a real thing, sir.
too much money. When me I go school, we
Even here,
start
it's
one
not so expensive, sir.
Bigfoot. Them still have in Jamaica.
Yes, sir.
How
Yes,
much a
sir.
Bigfoot? $20.
Sir, I
What
believe
you,
you.
how much?
Sir, I don't know.
All right, well, I put the
I
change in
think
that.
it's 130, sir, where I get to. It's 130.
Yeah. So if you notice when I did this and I run it, there's nothing else for the counter to do because we have not yet given instruction to calculate the price. So it just stops there. But this is very important because what it does for us is allow us to test the program and find out errors quite easy, especially when you just start on the programming. I run every time I type something new, I run it. That's how I started. And that reduced my anxiety and helped me to better be able to detect and fix errors. So the next thing that we needed to do was to find the total price, right? And I'm going total price, and based on our pseudocode, we needed to do price one plus price two plus price three. And then from here, okay, you know, notice I give me an error, right? Let us show me so there's an error. Notice me never have the price three. So I have to go back there, go change that to price three so I can fix the error. Good. Now from here, we just needed to print the price. And so in here, the final price. Final price is open bracket, and we would put total price there. All right. So this program is working fantastic. Now, there are a couple of things that we did go through a while ago. So we did talk about test data. Deandra, remind me what is test data.
Sir, I don't remember.
No, you don't get to do that. You get to go looking at your book and come back and answer me.
Okay, sir.
I mean, I intend to wait too long.
Sir. Oh.
Mhm.
So, no, sir. Malik wants to answer, sir.
All right. Go ahead, Malik.
Test data is sa- sample input data that is used to check whether a program works correctly under different conditions.
All right. So that means Deandra is going to give me some example of test data that I can use now. Go ahead, Deandra. What can I use? Enter the first item.
Examples, sir.
Me want to test my program. So give me some data we can use. Me an item. What we sell.
Sir, something.
I can't type something, I need to know what thing name.
Sir, a laptop.
Laptop. Okay. What the price of the laptop?
1,300 USD.
Jesus.
Oh, children. Can't put no USD on it. Okay, cool. Next. Give me one next item. Next
Wireless
test data.
earphones.
Oh,
Wireless earphones.
wireless what?
Earphones.
This young people now going like me young, you know, me I get old, you know. Watch it, you know. Price. Remember, son, never there around
75
when 9/11 are going, you know. So,
$75.
75. Next.
Sir, one iPad.
iPad. And price.
Sir, 200 USD.
200. So it's cheap. And we can find a store there.
Sir, I'm making up the price, by the way.
So like if you find a store there. If I couldn't have rip off, when if you send ice, go look for them. All right, so there you go. So notice that that works. Now, just to put in a bit of application, so I did speak about maintaining, right? So one of the ways in how we maintain it, look at this. If you notice, I created a white space. Why do you think I created a white space between different blocks of my code? These are what I call white space. We don't call it empty line. Why do you think I did that?
That's clear to understand, sir, and it's not jumbled up,
Fabulous. So when you
almost like
talk,
paragraphing.
fabulous. So we're applying those same principles when we talk about maintaining. We want to make sure that our code is orderly, it is easy to read, it is not confusing. All right. Notice as well that it is very logical. So I didn't just collect all the items, then collect the prices, because some people might become confused by my code. So I try to be to have them in certain amount of blocks, relatable blocks, so that as you see it, you can understand it and you can hopefully cross it and later pass it. Now, the other thing that we need to be able to do in our programs, yeah, we need to be able to write comments in our programs. Now, when we did just start out, I would have expected you to write comments. So the first comment we should have had is something like what the program will do. So this will accept 3 items and their prices and print the total price. Why do you think this is necessary? Rajin, why should I put that in there? How is that helping to maintain my program?
Sir, repeat it.
Okay, I have just placed a comment in my program. Why do you think this is necessary?
Um, so that it stays in the command.
Well, it doesn't affect the command because the computer don't even read that. Once we make it a comment, meaning we put an hashtag there, the computer ignores it. So it's not even there for the computer. Why do you think it's there? Right. What about the others? Come on. Jade, Malik, Katrina. Why? What is the purpose of a comment in a program? Why do I need to put that there?
Just give them a general idea of what is going to happen when it's run.
Why would that be necessary if, let's say, you and I are working on a program together? And why do you think this is important for, let's say you did this, you did the first part of the program, and I did go and chill. I'm going to come back now to continue to work on the program. How can this help me?
It's an easy to understand reminder, basically.
Nice. So it tells me what you were trying to do. Yes. And so I can carry on working. So in your exam, they will ask you about maintaining program. One way we maintain program, as I said, is white space, making it easy to understand, is also adding comments. So I could add a comment here, accepting and storing price and name of first item. all of this is just there to help other persons, help myself, right? So when you do my SPA question, for those of you who are doing it for me and for those of you who are doing it in your school, you need to have comments in your program because if you're going to get points for it, I think it's 10 marks, not 10, maybe 5 marks for just that in there. And the purpose of that is to show that you're maintaining your project. You're making it easy for other persons to understand the program. That includes your teacher. It includes yourself, because sometimes you could leave a program and come back and you don't remember what you were trying to do. Right? So it's very important. Finding the total. And this might not be, obviously necessary now. It may not look very obvious because it's a simple program. But when you have to write pages of program, long programs, it is good to have comments because comments acts like footnotes. They sort of help persons to understand what is happening. Okay? So put in the final price. Okay? There you go. So I hope that persons have done complete this, whether on here and added it to yours. So what I'm going to ask you to do now is to start working on the other one, same process. Hopefully, after all of that I've gone through, it would give you a bit more confidence and
So I
understanding.
wasn't hearing you for a minute.
Yes,
Wasn't hearing you for a minute, sir.
Yeah, so what I'm saying is you are going to carry on now to work on the other defining diagrams, pseudocode, program, etc. Make sure your programs actually have comments in there, as we want to do proper practice on it. So we only have 10 minutes, so I would love for you to start it now. Obviously, everything is going to be due for lesson 3. Yeah, everything is going to be due for our next class, yeah? Next class is what, Thursday? Yeah, homework. But again, start it now. So I've sent you my copy that I have typed and screenshots. If you want to store that for yourself or keep it as an example, so as you are working through, you can always refer to the things that I have said. Yeah, types of languages, program languages. Program notes. Notes. Let's throw this over to this chat. As usual, while I'm here, if you have questions for me, please, feel free to throw them at me. Programming is my favorite part of of this course. Yeah, everything else, just do it for formality, but this I love. So yeah, feel free to throw your questions at me and I will try and answer them. Yeah, and I've also sent you my rough draft of notes, so just in case you had missed anything that I was explaining. I've also thrown in the chat. Please make sure you're keeping a nice storage of all the resources that we have been using, because everything I've given to you, I've kind of stayed to the point of what you need to know for the exam. So I'm not giving you anything over. I'm giving you within scope that you can utilize. And so when time comes for study, you want to have your materials ready. Sometime around March, mid-March, we're going to do a mock exam, all right? Paper 1 and paper 2. So that is to kind of gauge where people are performing for the first, somewhere there in March. Yeah, so gauge where you're at. And so we can look at what areas we want to revisit and we want to fix up on. Um, Make sure you're here next Thursday. I am going to do a little bit of programming, maybe, and then I'm going to try and move on to network security. So we have already done network, so we're now going to move into network security. Um, After Saturday next week and Thursday the following week, you should be able to take on the programming aspect of your SBA, granted that you have been paying attention to the practice questions that I have given to you and that you have been practicing these questions, right? If you practice these questions, you will get the knock. You might have a few minor errors in your actual SBA, but it will not be anything significant because you would have practiced good practice from here, from basic up. Remember that the way to do well at the programming is actually to practice. You really can't study this. You just have to practice and allow it to become a part of you. Refer back to your notes each time. And of course, yeah, ask the right questions. Yeah. I feel like Colton and Malik are gonna try to take on the little man computer. Am I wrong or am I right, Colton? You look like the type who I got things, want to do something more than everybody else.
That's hilarious. That's hilarious. Truly, truly, that's hilarious.
Yeah. Yeah, we have Microsoft Access to finish. I think we have just queries to briefly revise.
Yes, sir, because we need to go through that. So,
Yeah. All right. So
but I
yeah,
started the
we'll
website, sir. I
again.
started the website. I
Oh,
started the website.
nice, nice. Yes, website is kind of like self-explanatory. Um, Probably the only thing I'm going to do is to give you some notes relating to the actual things you need to know. But as relates to the drag and drop, it's just it's just getting in the groove and coming up with a creative thing that you're trying to do, and should be fine. Yeah. I think we have one more technical area to do, which is Microsoft Word. I've left that for last because that's probably quite basic. Maybe it wants you to do a mail merge, and yeah, probably about it. Where is concerned. So I need to like cover the high volume theory stuff, but also find time to do the more technical part. So we have done spreadsheet, which is good. Done website. We haven't done the word component yet. We have done problem solving. Perhaps the only thing we haven't done in problem solving is loops, which I intend to do next week. Um, and then arrays. But yeah, we've done flowchart, pseudocode. Oh, yeah, we need to do dry run next week. So we need to look at uh trace tables. Uh, yeah, trace tables. It seems that they have removed truth tables from the curriculum, but yeah, trace tables are still there. So yeah, trace tables are fabulous. Let's see what else we haven't touched. Yeah, database needs to finish up, but that's fine. See what's going on here. Okay, finish that. Word processing, web design. Um, yeah, we have done Oh, okay. So yeah, and then we're gonna come back to some theoretical stuff, which is basically just social and economic impact of IT. Uh, we can leave that for like the last topic going into the exam, as that is more theory and easier to digest. Um, yeah, we still have some verification, basic stuff, basic stuff, fundamentals of computing. Yeah, I think we're doing well in terms of what we have covered. I think we have really just covered a lot of details stuff in there. So that we in good standing, good standing. Katrina, tell me how is the class gauge me based on what you're doing at school? Are we covering things you have covered? Are we covering things that are strange or what? Are we bringing clarity? Let me know.
Covered certain things.
We've covered everything that you have done in school already, or what?
No.
Okay. So that means you should be at a good advantage of your fellow mates. All right, good. That's good. That's good. Malik, what about you? I know it's only 2 classes, but um, how has been the programming experience? Have you done all of this already, or yeah?
The last topic we did, which was Thursday,
Mm-hmm.
I covered that language, that topic in class already, but
Mm-hmm.
I'm just now learning about this topic.
Okay, programming. Okay. So what year group in? 11?
Yes, sir.
And
We're at
what programming um what what type of program compiler using? Editor. What language? Sorry.
we haven't started that yet, sir.
Oh, right, good.
We're in
Yeah.
we're in database.
Mhm. Okay. Yes. Yeah, we covered the database early in about December there about. Yeah. So yeah, you can actually do your SBA. And if you learn Python well, Python is much easy. Yeah, but sometimes if your teacher is not very familiar with it, they probably might think, boy, it's going to be hard. So they might dread you trying to do it in Python. But I mean, if you know it well enough, and yeah, you can actually code your program in that for your SBA. What she needs to be able to do is to see it work. And once you're good at that, then that's fine. All right. What school you attend?
Frankfurt High School.
Very good. Yeah, cool. All right. Cool, 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 cool. Uh, Jade, how is my teacher friend doing?
Good, good so far.
Okay. All right. So where you guys up to in class now?
The same place as what you're doing.
Right, where we're at now.
Yep.
Okay. All right, cool. Good that is happening. Nice, 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 nice. So yeah, great. Great to hear. Great to hear. Reggie, what about you?
Sir, I just most of the SBA, sir. No programming or nothing, so this is all new to me.
Oh, all right. Well, that's it. Well, sometimes students have to kind of take some ownership, and I think you guys are doing that. That's why you're going to a class to do it. So yeah, well, now actually get into the practice of it, and once you get into the practice of it, it all start making sense for the SBA part. It's good when you can actually, just yeah, have an advantage in moving forward with that. Yeah. All right. Cool. That's good. That's good. That's good. All right. not asking Colton and Jade nothing because they are children. They are still in year 10.
Sir, I'm in grade 9 actually, sir.
9, there you go. Even more of a child. But that's good. All right, so yeah, Colton, I'll come back to database in a little while. Yeah, just what I wanted to do was because there are so many people who actually didn't do anything about programming or customers going into it. I wanted to do a lot of that, kind of get persons on their way. Yeah, so in after about 3 classes, give me about 3 more classes to cement what I'm trying to get out of you. Once you guys do the practicing that I've given to you, after about 3 more classes, we should be able to move on and close the other gaps that we need to close, and we should be good. All right, this is where I'm going to leave you all. So yeah, please work on my homework. Finish lesson 3 for me. Get the practice in. As I always say to persons, it is better to try and fail than to fail to try. If you fail to try, you have not given yourself a chance to succeed. And so try it. If you fail at it, you know how to message me. Send me a message, send me an email. I'm happy to explain, provide you some other sources that you guys can, yeah, be good. All right. With that said, I want to say have a great evening and see you next evening, afternoon now, night for me. So have a great rest of the day. Finish my work from now. That will not have to tell me so I have work for doing a week. I don't have chores to do. Done my work today and said it come give me so we can mark it. All right. That's it, guys. Have a good day. Take care.
Right, sir.
Bless you.